Hello, I'm John Nelson, and welcome to my Week 5 exercises for advanced financial modeling. This week was very interesting because last week I had to just submit my last week's assignment because a broken ankle is not fun, and missing class where you download software like NumPy will leave you a little behind. But luckily, Mr. Zhang gave me an extension, and I just sent all of y'all that email. And Week 5 went very more smoothly now that I know what I'm doing. I actually have a interesting line of code. I got one that I found a way to shrink my one code down 130 less lines compared to I was using ChatGPT and DeepSeek, and I was able to shrink it down. So this video will be way shorter than usual. 133 less lines in this code. So as we can see, line 1, import NumPy as NP. That's all we need. Number 1, portfolio tracker. Symbols equals AAPL, Microsoft, MSFT, and GOOGL, Google, obviously. Quantities, 150, 75, and then the prices of those stocks are 190.5, 375, and 140.5. Then we have position values equals Q times P for Q, P and ZIP quantities prices. Total value equals sum position values. And then we print portfolio values. As we can see, portfolio values is at the very top of the terminal, 48,337.5, but we will wait to go to the terminal until we finish going through the full code. Moving average calculator. That's on line 13. Historical prices equals bracket 100, 102, 101, 105, 107, 110, 112, 115, 117, 120. Yep, and that is all for the historical value. So I believe it's between 100 and 120. Def moving average prices window. Then we have the return NP mean prices I minus window I for I in range window lin prices plus 1. And then we have MA5 equals moving average historical prices 5, and then MA20 equals moving average historical prices 20 if lin historical prices is greater than or equal to 20 else. Then we have signals equals buy if MA5I is greater than MA20I, or else you would sell for I in range lin MA5 if MA20 else. So we print 5-day MA is MA5 and print signals. So those will be in the terminal as well. Bond calculator. Bonds equals 1,000, 0.05, and 10, 1,000, 0.06, and 5. This is face value, coupon, and maturity. Def calculate YTM face coupon years price equals 1,000. Return coupon times face plus face minus price divided by years divided by face plus price divided by 2. So that's obviously the formula. And then again, another formula, YTMS equals calculate YTM times bond for bond and bonds. So then we print yields to maturity to show these bonds. And by the way, that's what YTMS means in those equations, years to maturity. So now with our new screenshot, as we can see, we just went over line 30. YTMS, years to maturity, equals calculate years to maturity times bond for bond and bonds. And then we print yields to maturity in the terminal. If we look at line 33, we can see price analyzer, daily prices equals NP array, 100, 102, 101, 105, 107, 110, 112. You know the drill. We're going to 120. Daily returns equals NP diff, daily prices divided by daily prices minus 1. Or negative 1. Print the highest price, NP max daily prices at index, NP arg max, then print lowest price, NP min daily prices at index, NP arg min. We already just did this too. This is just printing in the terminal the highest and lowest price for our exercise. Then number 5, asset allocation tool, exercise number 5. If we look at line 40, we can see number 5, asset allocation tool. 41, current alloc equals NP array 0.4, 0.3, 0.3. Target alloc NP array 0.5, 0.25, 0.25. And then rebalancing is target allocation minus current allocation. Then we Then we print rebalancing needs. So all the needs we need rebalancing in the terminal. Number 6 was risk calculator, a simple risk calculator. Returns equals NP random 100 divided, or 103. This is the simulated returns for 3 assets. Then we have correlation matrix equals NP correlation coefficient, which is returns T, and then volatility equals NP standard deviation returns axis equals 0. Then we print correlation matrix, and print portfolio volatility. And that is also for the terminal. Now let's look at the terminal. So now if we take a look at the terminal, we can see all of our coding has been ran and we can see our results. Portfolio value came out to be 48,337.5. Then we have our 5-day MA of values of 103.0, 105.0, 107.0, 109.8, 112.2, and 114.8. We have yield to maturity, which is 0.05 and 0.06. We have the highest price, 120 at index 9. The lowest price was 100 at index 0. The rebalancing needs, 0.1, negative 0.05, and negative 0.05. We saw that. It was pretty obvious in the code, as the rebalancing needed was just the equation. We just needed to lower each amount by 0.1, 0.05, negative 0.05, and negative 0.05. Then correlation matrix, we have negative 0.09623.876, 0.03573.213, negative 0.09623.876, 1.00389.128, 0.03573.213, 0.00389.128, and 1. As you can see, there is a line of ones, which is all good and looks good. That's what you want to see. Then finally, portfolio volatility is 1.0770821.8, 1.00962.148, and 0.78506.916. Thank you so much for watching my Week 5 Advanced Financial Modeling exercises, and I will see you next week.